Yeah, we'll get started on our maths. Very easy.
Yeah.
Very easy. Very easy. Okay, Ming, time for maths. Did somebody spill something by the bin? Looks like there's a big stain by the bin.
Yeah. Coffee.
Who spilled what?
Coffee.
Was it you, Marwan?
No, it was the teacher.
A teacher? Which one? No, let me guess. It needs to be someone who always has coffee, so that...
You.
True, but I don't spill it. Lorraine always...
It was a male teacher. He wears glasses.
Your class.
A male teacher wears glasses. Come on, Steven. Come on, Steven.
Wears glasses. Tall, skinny, young, old.
He has glasses.
Wears glasses.
It's a temporary.
Like your age.
Like you have higher.
Same office with you.
Yes, that's how far that you.
Huh?
He has five.
Yeah.
Connell, is it?
No.
A Connell?
No.
No, he has head.
It's certainly not a good skill.
He came
No, that's Connell.
He came
Connell. He spilt it. How did he manage to do that? No, seriously, like, was he trying to throw it in the bin and he missed? Or what happened?
No,
I don't know.
I didn't see.
I didn't see it.
It sounds like he made you be silent on it. He told you not to say. Oh, he's messy. Messy. But we can't say anything because he's in charge, so you know, I guess he can be as messy as he wants. Right, the first thing is, we've already talked about degrees and radians in physics. Did I show you the quick way to convert? So for example, if you have a number in degrees and you want to convert it to radians, did I show you the quick way to do that in physics or not? No, the quick way to do that is you multiply by pi over 180. And if you want to go the other direction, radians to degrees, the quick way to do that is to multiply by... Yeah. Now, I'll give you two quick examples just to practice. I want you to convert 62 degrees and 2.1 radians. My goodness.
It's
1.08 radians.
Yeah.
And then next. Huh? 120. Okay, 120 degrees.
Yeah.
And then lastly, I want you to convert 60 radians, but I want the answer to be exact. What do I mean if I say the answer is to be exact? Do you remember what that means? Ming remembers. I can see it in her eyes. She remembers. She's going to tell us. Go on, Ming.
Pi over 6.
Good.
Pi,
But what does the word exact
no,
mean?
Pi over 3.
Yeah, but what does the word exact mean?
Exact mean?
Yeah.
1 over 3.
No, explain it. What does exact mean? Ah, yes, okay, I got you. Now, exact means exact. Thank you for clearing that up. Bello, do you know what does exact mean?
Like no decimals.
That's it, good man. No decimals.
No
No decimal.
That means 1.
So, what is it here?
Pi over 3.
Pi over 3.
Yeah, 1 over 3.
Yeah, yeah. Is that okay?
Yeah.
Okay. Now, next thing we have to do, I think, again, what's nice for you guys is you've already done this in physics. A little formula for a right angle triangle. He's Greek. What's this called? Pythagoras. In Arabic, Pythagoras. Yeah. Close. Yeah, okay. Yeah.
What is it?
Pythagoras.
You said you're close, that means you don't get it.
No.
And what's the pronunciation?
It's okay for somebody from Dublin. You know?
Now I want to hear
Go on, what is it in Arabic?
Pythagoras.
That's what I said. Yeah.
Pythagoras.
No, I think I did a better job, right? Yeah. Right, a squared plus b squared equals c squared.
Yeah.
And that's really it. So let's just practice with an example. Give me the answer to 2 decimal places. 2 decimal places. What would it be?
What is two decimal place?
2 dp. 2 decimal places. 3.61 is it? C squared equals 3 squared plus 2 squared. C squared equals, what's that, 13? C equals root 13, which equals 3 point...
1.
Yeah? 2 decimal places.
6 0 fractions.
Yeah, 2 1 there. Okay, that's alright, isn't it?
Yeah.
Now, what we can do next, we can talk a little bit now about sine, cos, and tan. Something I hope you already know, but we'll just clear up the vocabulary. So, in our right angle triangle, if this guy here is the theta, the angle, what is this side called? And what's this side called?
Adjacent. Adjacent. Adjacent.
And this side?
Hypotenuse.
Yeah.
Hypotenuse.
Stop giving it to me in Arabic, okay? Just stick to
That's how we
English.
say it.
That's how we say it.
Yeah, okay.
Adjacent.
Really? Yeah. No, seriously, you say adjacent, is it? Or?
Adjacent.
Adjacent. Like the ja.
Adjacent.
Okay.
Adjacent.
Right. What is sine theta? That is O over A. Opposite. No, O over H.
So
Kato. Yes. Cos theta is A over H, and tan theta is O over A. But we also mentioned this in physics as well, didn't we?
Yeah.
What's really nice about this is we can use our calculator to find angles now. So for example, suppose I have a triangle. Well, let's actually use the example I had a moment ago. What did I say? 2 and 3. And I would like to know, let's say this angle here, theta. Well, I have to use which one? Yeah. And you know this from physics. Theta would equal tan inverse 3 over 2. Now, what is that? Okay. Now, what about this triangle? I'm going to put the theta here. I'm going to say this is 3, and this is 5. And I want the theta, and I want it in radians this time, so you need to put your calculator in radian mode. Also, do we use sine, cos, or tan here? Cos.
Adjacent.
Yeah, okay, give me the theta here in radians. Yeah. Theta equals cos inverse.
So you have
3
to
over
check
5.
theta radio.
It's like shift mode or something like this.
Or can't you just like find it?
You could convert it then, yeah. What is it, Rahman?
0.927.
Radians. Yeah? Now, I'm going to give you a question and you cannot use your calculator for the next one. Can I scroll down?
What? Right? Oh.
You need to be using radians on your calculator.
It's really-
Radian mode. Do you have radians mode?
Options.
Yeah, menu, no, a shift, menu, angle, radian.
Okay.
No, on this one.
Yeah.
Now try it.
You have shortcut here.
Oh, do you? Okay, well, Marwan, you can show him in a minute.
Options. It's number 2.
Can I scroll down, guys? Do not use calculator
Okay.
for this one. Tan sine inverse 0.8. No calculator.
So 0.8 is sine, not cosine.
Did you ask me anything, or you're talking to yourself?
No, I just want to know 0.8
Yeah,
is
yeah,
4 over 3.
is
yeah. But
it's belonging sine or belonging
final answer though.
It's belonging sine or belonging tangent.
Okay, if you're not clear, I'll use brackets. So it's like this: tan bracket sine inverse bracket 0.8 close close. How's that? Clearer?
1.333.
You use the calculator?
I only checked for 4 over 3, but I didn't do the calculation.
He did.
Don't know if I can trust this class.
They even know how to start.
Yeah, yeah.
Just do.
David will tell you. Step 1, you take your calculator out.
Press the on button.
Yeah. Step 2, yeah.
Press that button.
Yeah. Right, okay, let's see who can actually get it.
Oh, it's actually 10 over 8 over 10.
No.
Oh, 30, 37?
No.
30, 34?
No.
I told you guys the answer now. 1.3.
No, see, no.
You have to convert it to rads.
No,
No.
Oh, you
You need to
give
do
the answer in
scientific
degrees.
first.
37.6?
no,
You give the answer in degrees.
Well, I know what to do.
doesn't matter.
Opposite to
Anyone got it?
4 over 3.
Yeah.
I don't use it. It's not 0 that I use.
You got 4 over 3?
I think
Press answer.
How'd you get 4 over 3?
it's like 0.8, it's like
8 over 10
8 over 10, it's like
equals to
4 over 3, then I do the triangle.
Yeah, okay, close enough.
8
Right,
over
so
10 is
look,
4 over 3.
Here's the
4 over
answer.
5.
Now, in the exam, it would be something like this. Tan sine inverse 0.8 is 4 over 5. Okay? This here is an angle. What angle is it? It's the angle when you have a right angle triangle with sides 4 and 5 here. Opposite and hypotenuse. What's this side? 3. I want the tan of this angle.
4 over
Oh.
Yeah.
Yes, sir.
That's
I
quite
did
easy.
since.
Your calculator
Simple
makes sense.
something.
Yeah. Alright, write that down. So,
Oh, this is quite easy.
well, now it looks quite easy. After I've done it.
That's how all.
That's how all it always
everything
goes,
that
yeah.
involves Math and physics is.
Yeah, I know.
When you do it simple. When you say do it,
in university, I only ever had to repeat one exam, and it was kind of like a physics exam, mechanics exam, because I remember thinking for the whole year when the teacher was doing questions on the board, like, it's easy. I could have done that. I don't need to practice. It's fine. It's easy. The whole year. And then I went to do the exam. I'm like,
Wait this.
how do you do this? So I know my biggest worry is always that my students will look at the questions and think, shh, easy. I don't need to practice at home. And then they sit the exam and then they go, oh, yeah. You know.
But even when you do it, I don't see it as easy.
Oh, good. That's good. That's good, actually. I get worried when students
Most of
think it's
the
easy.
things you just did like, how did he know this? How did he know that?
Okay, no, good,
They are
good,
saying
good,
it
good,
such a lot.
good.
It just sounds-
My fear is always that you think it's too easy and don't practice.
maybe my one.
All right, did you write that down?
Yeah.
Can I scroll down? Yeah, okay. So, homework, which you can start, we'll say 1 A, B, C, 2 A, B, C, D, 3 A, B, 4 A, B, C, D, 5 H, J. No, I'm saying H, I. Now I know they're very quick to do. In fact, I really think you should have all these finished before you finish for lunch, okay? So
Yeah.
see how quickly you can do them. I think you can get them finished now, yeah?
Maybe.
I think so. The only question you can't use your calculator for is this one, okay?
Teacher, which function is for you show me before?
For what?
Perhaps.
No, Marwan has a shortcut for converting.
I think just for
Not for his.
what? No. It has, but
Is it a shortcut?
just for one calculation. I don't change the mode.
Oh, you can just
Both.
temporarily.
Yeah.
Interesting, okay.
So how can I put the degree inside?
For question 1?
Yeah.
Yeah, you don't need to worry about the mode on the calculator for question 1. You can just use the formula I gave you at the start, which is these ones.
Oh.
That's all. Did you write down the questions? Yeah, you have that?